So thank you to everyone who's joined us here today to talk about how to make IoT as easy as pie. We'll be walking through a basic example of how to turn a Raspberry Pi into a weather station and integrate it into the AWS IoT ecosystem. But first, a quick commercial on who CleanSlate is and a little background on myself. So CleanSlate, we're a local consulting company that's an AWS Advanced Partner specialized in application modernization using cloud-based technologies. We also have partnerships with complementary companies like Docker, Microsoft, Salesforce, et cetera, to help companies in multiple different areas. My name is Darren Mills. I'm the Director of Technology for CleanSlate, where I help align our technical strategy with the demands in our market. I've been in the industry for about 20 years, and I started out as a Java developer, which led me into the enterprise integration space. And recently, I've been spending about the last 5 years building those solutions in the AWS platform. For today's talk, I will start out with an overview of IoT for those of you that may be new to the technology and talk a little bit about where it's at in the market and some of today's challenges we face. Next, I'll give an overview of the AWS IoT platform and highlight some of the technologies that we'll be focusing on in this segment. Some of the other conference talks will focus on the different AWS IoT offerings. So by the end of the conference, you should have a pretty good handle on the platform's capabilities. Finally, we'll talk about and demo how to implement a weather station using a Raspberry Pi device and how it integrates into the AWS IoT platform. So Internet of Things, commonly referred to as IoT, has been around for about 30 years. But within the last several years, we've seen an explosion in the market. By definition, IoT is a system of devices connected to the internet with the ability to collect data with no human intervention. That's a rather broad definition, but that's exactly why the market has exploded. With the advances in technology to make things smaller and cheaper, companies become very creative with their efforts and to take advantage of the space. Things have become so cheap, they're flooding the consumer space, and I imagine many of us have at least one IoT device in our home, if not more. They range from things like home automation systems like Alexa, Google Nest, security system and video doorbells like Ring, health monitors like Fitbit or Apple Watch. I even have a Roomba, which is an IoT device to automatically vacuum my floors. But they're also used to create other smart devices like diagnosing your automobile or helping with the flow of traffic by optimizing stoplights. It would take a step back and look at some of the original reasons why IoT was created. It may become amusing just about how lazy we can be. Since today we can do just about anything without having to leave our recliners. The first IoT device was the brainchild of a professor at Carnegie Mellon University, where his office location was a very long walk to the Coke machine. He would often venture to go get a drink and find either the machine was empty or recently just stocked with warm beverages. So he decided to create his own circuit board that would interact with the Coke machine to measure the inventory and check the temperature. This ensured his long walk was always met with a nice cold Coca-Cola. This was later followed up by a publicity stunt called the Internet Toaster. You could start the toaster via the internet, but you still had to manually load your bread, so it was kind of pointless. The IoT acronym was coined in 1999 as the title of a presentation about how RFID chips would change the world. As an afterthought, he really thought it should have been called Internet for Things, but the name had already stuck. And one statistic that I find amazing is that there are more IoT devices connected to the internet than the world population, thus our need for IPv6. Although the market seems to have adopted IoT technologies, I like to use this Gartner hype cycle as a resource to understand where we're at within the technology adoption. This is the hype cycle from 2018, and it helps gauge the maturity and adoption of emergency technologies, and it's divided up into 5 different phases. The first phase is the technology trigger, which is where the incubator and proof of concepts and new technologies are formed. The second phase is the peak of inflated expectations. I love this one. It's when companies believe this new technology is the silver bullet to all their problems, and so they all start building their own implementation. The third phase, which is probably my second favorite, is the trough of disillusionment. This is when projects fail because of either poor implementations or the lack of business value. Most of these initial projects will fail, but some will succeed and set the foundation for the market to utilize. So for instance, I have 3 different smart appliances in my house that no longer have applications that support their IoT functionality. They were developed during the second phase without even asking the consumers if they wanted it. So I have a washing machine that will tell me when the washer is done, and I have a refrigerator that will tell me the temperature of my refrigerator. both things that I don't really use, but I'm not going to shame the brand name that stopped maintaining these packages. The next two phases are the slope of enlightenment and the plateau of productivity. These are when technology starts to become more mainstream and stable, mostly because of the widely adopted frameworks and standards that help companies from making the same repetitive mistakes. This is kind of where I feel IoT is at today, and platforms like what AWS has created helps us accelerate its adoption. So let's take a little bit of time and talk about why the IoT arena is still a complicated space and the challenges that companies have to face to succeed. So communication must be quick and it must be reliable. Security is paramount. You must be able to handle authorization, ensure open ports are not compromised, and ensure encryption of all your data exchanged. Presence detection is required to maintain the state of the device so we can know whether it's online or offline. And you must be able to support all of these requirements, but minimize the power consumption. And additionally, you have limited bandwidth, so you've got to ensure your devices are not chatty. So one or two of these problems are not that hard to implement, but when you attempt to solve all of them with little to no standards, it becomes a very difficult challenge. And there's also another challenge that is often overlooked with the IoT, and that's what you do with the massive amount of data that's being generated from all these devices. Many of the business drivers behind IoT was to capture data about something, but when you have thousands or millions of devices deployed and collecting data, it can be difficult to manage. So you have terabytes of data that are being generated, which lead to issues around managing your storage capacity. Security is obviously still a concern when you have that type of data volume, but also privacy issues are something that need to be dealt with, because how do you ensure the consumer information is removed to prevent the perception of profiling and eavesdropping on personal behaviors, a la our Google Nest or Alexa devices listening in on our home conversations? And most importantly, what are you going to learn from all this data that's being collected? To solve that problem, we'll maybe lean upon AI and ML to help analyze what it's telling us so that we can make better business decisions. So let's transition a second to learn about what the services AWS offers with the IoT platform and just how they might help mitigate many of the problems that I just outlined. Their offerings can be categorized into three different domains. We have the device software, which are products that make creating IoT devices easier. We have control services, which are products that make interacting with their devices easier. And we have analytic services, which are products that help us learn from the devices from the data that we're collecting. During today's presentation, I'm going to focus on the control services, but I know some of the other products are being talked about within the conference as well. First off, let me pivot to one of the technologies that is considered the entry point into the IoT space. It's the AWS IoT one-click service. It's catered to the beginner IoT developers and provides a very easy to use mobile interface to register and develop prepackaged Lambda functions to send email, send SMS notifications, and many other things. It has the ability to execute 3 different functions based upon the button action: a single click, a double click, or a long click, each mapping to a different Lambda function. Although this version of the enterprise dash button has been discontinued, you can still purchase them on eBay, or there are similar devices from AT&T that are actively being developed today. So this one-click technology was the basis for the Amazon dash button that let you replenish your home goods from just a single click of a button. This was Amazon's first true IoT device, and they announced its availability on March 31st of 2015. This idea was so absurd that many thought it was an April Fool's joke, but nope, it was a real-life device, and over 250 different buttons were developed. As I mentioned before, data is the real business driver for many of these IoT devices we see today, and the dash button was no different. Amazon was able to learn about many of their consumer buying characteristics to help them augment their Amazon Fresh grocery service. However, over time, the product offering was discontinued last year, mostly because the functionality was replaced with Alexa, but also because they were facing consumer rights violations in Europe due to the price not being disclosed upon purchase. So I listed out some of my favorite dash buttons on the right, but some of them just blow my mind. I had to look up what poop bags was for, and I was disappointed to learn that it was used while you take your dog for a walk, which is going to be very helpful in today's situation. And that brings me to the #1 ranked fan favorite, the Trojan dash button. I'll let you do your own research on that one, but it certainly sounds romantic. So let's jump back and talk about some of the core components to the AWS IoT framework. AWS offers device software to help you build your IoT devices. FreeRTOS is an operating system specialized for microcontrollers that require low power. And then you have Greengrass, which helps bring AWS capabilities to the edge to help mitigate latency and connectivity issues. It also helps with privacy concerns to anonymize your data before it's sent to the cloud, which may be important in the medical or regulatory fields. And then just recently announced is the Amazon Common Software, ACS, which means to simplify the Amazon SDKs on your devices and help optimize their functionality. Currently, there's a broad and complex offering SDKs based on your device and coding language, so this is a great step forward. It was just released out in February. It's still in preview, and I'm not sure when it can become generally available, but there is beta software packages that you can go download. So AWS IoT Core, sometimes referred to as the hub, is the foundation of the platform. It provides you all the capabilities you need to connect and manage your IoT devices. Out of the box, you're provided with secure communication between the cloud and your device. You can implement business rules to do things with your data that you're collecting. And you can also mitigate the impacts of devices that go online or offline by having messages get queued and republished if necessary. These are called shadow devices. And it also supports communication over HTTPS, WebSockets, and MQTT, and custom protocols. But the preference is given to MQTT because it has the lowest amount of overhead and can handle the limited bandwidth that you typically have. So IoT device management is a helper service to the core and provides the capabilities to register your devices and manage them. As your fleet grows, you can divide them into groups and manage at the group level versus the device level. This provides you the ability to scale the fleet to a large number of devices, and additionally can help push out software patches to these devices when they're online, so users don't have to worry about any type of maintenance activities. Then we have AWS IoT Device Defender, which helps you secure your fleet of devices to identify security risks. It provides a pre-configured audit based upon best practices to validate both your AWS IoT configuration and your device configuration. This can be scheduled and trigger alerts to be sent to your administrative team, so they're always up to speed. It can also monitor device behavior and look for anomalies. So if you have a device that suddenly starts port scanning its network or sending data to a new IP address, then it could likely be a compromised device, and we'd want to generate a security alert in that instance. So this is a super easy service and cheap service to use, and it is a great way to keep your name out of the news, which is one of our goals. Then we have the AWS IoT Analytics services, and that offers everything your business needs to slice and dice your IoT data to provide meaningful value to your company. This ingested data runs through a series of self-defined pipelines to massage your data via Lambda functions. So you can do data conversion, data enhancement, whatever you need to do. There's also no need to worry about the underlying storage, as it's optimized for time series data and allows you to run ad hoc queries against it. It also has the capabilities to apply machine learning and visualize your data with Jupyter notebooks. This is actually bundled of about several different packages. Not an expert in this area, but I think there is a talk later today or tomorrow that'll talk through some of the different offerings that there are for this package. So we covered the highlights of the platform pretty quickly, but it is a single platform that can scale to meet your business needs. Each one of these products offer a ton of functionality, but when you combine them with the other AWS offerings, you get a very powerful tool set to tackle your challenges. So let's take a look at some of the challenges that I discussed earlier and see how the platform may or may not solve them. Although this is kind of my personal and somewhat biased opinion, I feel that AWS has a pretty good answer for most all of these challenges. Like I said, some of these services are not IoT specific, which is the beauty of the cloud. You get many other tools to be able to help solve your business problem. For instance, we have AWS Cognito, can help you with your security requirements and integrate seamlessly into your IoT platform. And then you have services like Amazon Macie that can help alert you to any sensitive data that's being exposed in your data. Overall, there may be a better individual solution here and there, but as a single offering from a single vendor, it certainly covers the gamut to get you started. So now that we've covered kind of the AWS IoT ecosystem, let's have some fun, put it to use, and create a weather station that we'll use to calculate the temperature and the humidity of my home office. So the first thing we must design is our thing that will be deployed. In this case, and being a true nerd and on CleanSlate's budget, I chose to use these components, which is a Raspberry Pi 4, which, for those of you who are not familiar with it, it's a mini computer with 4 cores and 4 gig of RAM running Raspbian, which is a Linux-based operating system. Super powerful, Wi-Fi built in. It's been a fun little play device to have. Then I'm going to be using a Raspberry Pi Sense Hat to provide the sensors related to the weather instrumentation. This device was designed as part of the Astro Pi program and was launched to the International Space Station in 2015. So it's pretty awesome. Finally, we have a Hologram Nova cellular modem to provide communication when the device is outside of wireless range. Unfortunately, over the weekend, I rolled my chair over the antenna and snapped it, rendering it useless. I decided to order a replacement on Amazon, thinking it would be here within a day or two. And unfortunately, with the shipping delays, it has not yet received. It's not yet been here, or it's not yet come. And it's supposed to be here today, which ironically is probably going to come right during the middle of my talk. So we'll skip the Wi-Fi connect or the cellular connectivity, but it's just essentially what we would do if we didn't have Wi-Fi signals. So let's take a little bit of time and talk about the architecture that will make all this happen. So first, let's assume our device is already registered and secured with the platform using the device management service, which we'll cover in a few slides. And let me get the laser pointer here. And so we have our Raspberry Pi over here. It's collecting data from the weather sensors. And this information will be captured and packaged as a JSON object that will get sent over as a MQTT message to the IoT core platform that has a topic defined. So during this exchange, a connection is going to be established and the thing will be authenticated against Cognito using its X509 certificate. Once authenticated, the message will be placed back on the topic so that we can have business rules that execute against it. In our case, we want to have a business rule that says we want to save the message payload into an Amazon DynamoDB. So that would be this path here. At this point, our rules are done executing. The message is purged from the topic, and we rinse and repeat over and over and over again. In addition, we have the device defender who's going to periodically audit our device and our IoT configuration to make sure that we don't have any type of security vulnerabilities. So we don't have any security vulnerabilities. So next slide. So now let's get ready to build a weather station. How we're going to do that is within 4 steps. So the first one's going to be how do we register our thing? Then it's going to be followed by how do you secure your thing? How do you develop and deploy your thing? And then finally, how do we test your thing? So first up, how to register your thing. The IoT core service provides a very easy to walk through wizard to get you your thing registered quickly. So we'll log into the AWS console, we'll search for the IoT core service, we'll select manage, then we'll go to register a thing and create a single thing, and we'll give it a name. This will take you to the page where we create the certificates used to secure and authenticate our thing. So in this case, we'll use a one-click certificate creation. And what this does, it'll create 3 new certificates for your thing, plus provides you the root CA for AWS IoT platform. So you'll get a public key, a private key, a certificate for your thing, and the root certificate. These should all be downloaded because we're going to use those in the future step when we get into the development aspect. Next, we'll go ahead and activate our device. So push the activate button. And then finally, we'll click the register thing button. Note there is a security policy that we'll need to define, but we will do that in a separate step. So congratulations, you now have a thing registered with the IoT platform. That's as simple as that. So now that we have our thing registered, let's talk about how we secure it. So underneath the IoT menu, we'll go to Secure and Policies to create a new policy. We'll give our policy a name, which will be Raspberry Pi Weather Station policy. We'll give it an action, which in this case, we're going to select all actions from the IoT domain, and we're going to select all Amazon resource names, and this effect will be for allow. Now, I know some of my security guys in the audience may be going, dude, don't select star, that's bad. But I'm doing that for a particular reason here. That particular reason is so Device Defender, when we run our audit, that's going to say, hey, guess what, dummy? That should be a little bit more restrictive. Don't do that. So I've done that on purpose, so don't criticize me now. Criticize me later. So once that policy is all defined, we'll hit create. Then we take that policy and we need to map it to our certificate. So simple step, we browse to our certificate, we attach a policy, we search for our policy, and we check it, and we attach it. Now we want to bind our thing to the certificate, so we'll do the same process. We have our certificate, we'll search for attach thing, we search for our thing, we check it, and we attach it. So now these three items are bundled together. We have the certificate, the thing, and the policy all bound together. So the bulk of the IoT security has been handled at this point, but we'll rely upon Amazon Incognito to do the authentication. Since our thing will not interactively log in with a username and password, we set up a pool for unauthenticated identities. This will help bind our thing, which has the policy certificate mapping. So we'll search out for Cognito, and we'll manage federated identities, and we'll go create a new unauthenticated identity pool, and we'll name it the Raspberry 4 Weather Station Identity Pool. And then down in the JSON object to define the policy, we'll actually take the ARN from our thing that we just registered, and we'll cut and paste it over here into the resources for the authenticated devices. So that completes all the steps required to secure our thing within the AWS IoT platform. Next, we'll review the steps required to code the weather station functionality. So now we get to talk to our Raspberry. The first things we want to do with our Raspberry is we want to go ahead and update it to the latest firmware. So that's the RPI update command. That'll pull down the latest and greatest, and so your Raspberry will be up to date. The next thing we want to do is once that thing reboots is we'll go ahead and run the standard Linux patching. So we'll do an upgrade, so we have all the latest patch levels of all the software installed. We'll also want to set up a project directory so that we have some place to stash our source code. Then we want to install the Synsat development kit. So it comes as a pre-built package that we install. We do need to reboot it because there are some the GPIO circuits that need to be started and enacted so that we can read the devices, or we can read the device from the Raspberry circuit board. And we also need to install the AWS IoT SDK for Python. So this is where I didn't use the version 2 of the SDK because the documentation is a little bit lacking, and there's a ton of resources online that give examples that are like my code, so I figured it's probably better for this audience and probably not as challenging for me to have to learn how to get all this stuff hooked together. And then finally, we want to copy the 4 certificates that we generated during our registration to our project's search folder. So this is our public key, private key, the thing certificate, and the AWS root CA certificate. So now we'll start to talk about the code that we use to write. So this is written in Python. First thing we're going to do is establish some of our imports. Here you can see we have the AWS IoT MQTT client. We also have the Synsat client that we're importing as well. And then I defined some logging just for troubleshooting, and some constants here that we can use to help set up our client connection. So mostly here we're defining is their endpoint, our endpoint port, and our input and output topics that we're going to use to transfer data between the device and the platform. So in this case, think of input as what's going to the platform, and output is what's being sent from the platform. So when we name our devices, or we name our topics, we're really thinking about it from the standpoint of the platform rather than the device. So here I took and defined a function to manage our IoT client. So this establishes the connection to the core, or to the hub. So you see here, I'm passing in the credentials for our certificates that we created. I'm also configuring some of the tuning parameters for the connections. I just took the default values, so to be safe. Then I have a couple of different other helper functions that are used to subscribe to the topic, publish a message to the topic, and then what happens when we receive a message from the topic that we've subscribed to. So I've also defined some functions to manage our SenseHat client. These are helper functions to capture and calibrate our sensor readings and define some logos. So the temperature is returned in Celsius, so I have a convert to Fahrenheit function. In addition, the SenseHat's installed directly above the CPU of my Pi, so there is some thermal heat that alters the temperature readout. So what I did is I took calibrated the temperature and I subtracted an average value from it to get what my office temperature would be. Also, something that's cool is the SenseHat has an 8x8 RGB pixel screen that you can use to toggle on and off. So here I defined two different logos. One is a raspberry and one is a checkbox. So I use these to help me notify of the status of when data is actually being sent to AWS or not. Finally, I get to the main function that is what's responsible for collecting the data and sending it to AWS. So the temperature readings are very, very sensitive, and depending on the CPU heat, they can vary in between readings. So to minimize the ups and downs of the temperature reading, I decided to take 15 readings over a 30-second interval and then average the values before I send them to my IoT platform. That seemed to eliminate some of the ups and downs of the readings and give me a pretty consistent average. Also define the JSON payload that we're sending to the cloud. So in this case, we have a device ID, which is we define as a constant. This is a unique ID that represents this device. I'm sending a timestamp in ISO format, which represents the time of when the temperature was taken. Then I'm sending the temperature and humidity both in float format as part of that payload. Now, the awesome part about this whole solution is from start to finish, I only wrote 139 lines of code. That's it, and that is including formatting and comments. So you could probably scrunch this down to something else, and someone who's better at Python than I am can probably even find additional ways to shrink the code down. But that's it. You know, we're talking less than 140 lines of code, and the rest of the solution is completely configuration based. So this takes a lot of the intimidation out of how we do IoT. So the next thing we talked about was that we want to take this data and do something with it. So we're going to store this data in a DynamoDB table. So I go ahead and back into Dynamo and I define a table called Raspberry Pi for weather station data with a partition key of device ID and a sort key of my timestamp. Then I go back into the IoT section and I create a new rule. So I select Act from the IoT menu and create rule, and I complete the form to get my to start the data collection process. So I have to give it a name. So I gave it a Raspberry Pi 4 weather station. Data to Dynamo is my rule name. The real important thing here is this rule query statement. So what this says, it's in SQL format, but it really means select star from the topic input / weather station. So this allows you to specify what topic you're going to gather data from. In this case, we're going to specify our input weather station, and we want to take everything from it. You can use the hashtag or pound symbol to read from all topics, but in this case, we want to target a specific topic. The next section is we'll click the Add Action button, and we'll select the import message into DynamoDB table. Now there's about 20 different actions you can choose from, so you have a lot of flexibility out of the box. One of those actions is to execute a custom Lambda function. So by being able to do that, you know, really the power of Lambda has been unleashed. You can do really whatever you want to do with it at that point. So very, very flexible if you need to be. So the next part of this is we need to actually do the mapping. So how do we get data from our JSON payload into the DynamoDB? So in this case, we're going to map the partition key to the device ID in our JSON payload. We're going to map the timestamp to our sort key. And then basically how Dynamo works is everything else is going to go into a payload column. So the original JSON payload that we have sent will get logged into that column that we can later inspect. We do need to create another rule or another role that allows the IoT platform to access DynamoDB. So in this case, I'll just call it the Raspberry Pi 4 DynamoDB role. We create the role, and click Add Action. And then finally, we're going to click the Create Rule button, and that's it. So now that we have all the code deployed, we need to figure out how to test the device. So the IoT core platform gives you some basic testing functionality to validate that you are both sending and receiving messages from your device. First, we'll test that we are getting messages from our device, and based on our requirements, we should expect to see something come into our payload into the core service about every 30 seconds. So we can actually subscribe to the topic that we're listening to, which is input/weather station. And then every 30 seconds, you should see a new JSON message appear. So the second part of this is, now that we know that we're getting messages, is let's confirm that we can send our device a message. In this case, I can log the incoming message. So what we do is we go to the published topic. We enter the topic name we want to publish to. So this is the output weather station topic. And then we confirm in our Python console that we're getting a JSON message. So in this case, we could do whatever we wanted to do with it. There could be, we could trigger the device to go to reboot, do whatever. In this case, I'm just choosing to log the message, but our functionality here is really limited to what our creation can, or what our imaginations can create. Finally, we want to see that we are actually testing the business rule that we wrote to log data into our DynamoDB in the format we expect. So we switch over to Dynamo table and expect the items that are listed. And here you can see I got a bunch of items. I've had my device running consistently since I think Monday afternoon sometime. So I can't remember how many thousands of messages that I've captured, but the thing's been completely stable, not had to do any kind of reboot to do interruptions. Really impressed with the Raspberry Pi itself. So that outlined all the steps that we need to take to set up your IoT platform from scratch. And at this point, we have a fully functional weather station logging data into the platform. So now let's jump out of PowerPoint and get into the Indy console to see this thing in action. The provisioning time to launch this from scratch doesn't really fit well within our time constraints today. So we'll review a lot of the configuration I did just to kind of give you an idea of the layout. But we'll also dive into Device Defender and look at some of the audits that have been scanned on my device and show how easy it is to resolve the issues based on Amazon's recommendation. So now let me switch over to my AWS console. And I think that should be good. So I've logged into my AWS console and I want to get into the IoT core. So I've already visited it, so I'll go ahead and, now I gotta log in. Get my two-factor authentication. David, I hope you're impressed. All right, so now we're at the IoT core menu. And this is just a quick dashboard of some of the statistics that we've seen, the connections I've been able to make, the type of messages that have been sent, and the number of messages that have been published. So you can see I went from, sometime on the 21st, really late at night, and what it's been for the last couple of days, been pretty consistent on the number of messages that have been published. And our rules look very similar, so you can see when I actually got my rule implemented and how many times it's been executed. So been great, and I didn't define any kind of shadow device for this scenario. But just to kind of talk about this menu a little bit, if I wanted to create a new device, I go to Manage Things and create a single thing, and here's where you get to the specify where you create the name. It's actually a really simple menu to go through. If I want to take a little bit of a look at my device, I can talk about, here's where I get the ARN at. So this is where I snipped out into the policy that we created into Cognito. I can look at the security. So here's my certificate. I can click on the security or on the certificate and see its ARN. I can see the policies that are defined to it. So here's the policy that I have. Here's where we specified the star. I can also check to see what things are bound to the certificate. So there is my Pi again. And I'm back here. So we can then take a look at the business rule that we defined. So I'll go to Act, and here's the rule we defined. And here is the query that we're using to capture data. Here is our rule that we created. So we take a quick look at that. So I got my device ID, my timestamp, and my payload. And then these actions can be joined together. So I can also have error actions. Well, let's take a look at what it looks like if I want to create a new action. So here's all the functionality you get out of the box. So there's quite a few different pieces of functionality that integrate with a lot of the different functionality in AWS. Like I said, though, send a message to Lambda. That is your wild card. So if you have to do something very, very special, you can certainly do it with that. So finally, let's do a quick test to make sure this thing's actually working and that I'm just not pulling your leg. So in this case, we want to subscribe to a topic. And our topic that we want to subscribe to is our input, because remember, we're in context of the platform. So we're looking at everything that's being inputted into the weather station. And I'll go ahead and subscribe. And now we'll have awkward silence while we wait for a message to appear. So I have my Pi sitting on my desk, and as I mentioned, when I send data to AWS, I changed the display from a Raspberry to a check mark. So hopefully I'll be able to sit here and tell you when the data has been sent. We'll see how quickly it shows up. Oh, there the check mark went, and there's my data. So we can see here, yes, my office is very hot right now. My wife is home today, and she has the doors open in our living room, and our thermostat is running full gear, and I just haven't had time to go tell her to turn that off. So yes, it's 75 degrees in my office, and I'm starting to sweat. But this is what the message looks like. We'll just wait for one more to appear, just to make sure there's no smoke and mirrors. And you can see kind of the differences in the temperature. So here you can see it's a 75.76. Now it's 75.77, which is probably a bunch of hot air coming out of my mouth right now. So we will go ahead and take a look at what happens if we push something to our device. So in this case, we will publish to a topic, and this is going to be output. And in this case, we could change this message to be whatever. This is what's going to get sent to our device. So I'll say hello from AWS IoT Console. I will publish to my topic, which now wrote to my device, which I'll need to switch over now to a new window and get to my Raspberry, and we'll see if it logged that message. So now you should see my Raspberry Pi. I'm running the program or the code right now. So this is the code that we reviewed earlier. This is the code that's running. And you can see down here that our topic was logged and our payload was hello from the AWS IoT Console. So this confirms that I am both sending data and reading data using the IoT platform. And just not smoke and mirrors, we're still publishing weather data in the background. So this doesn't interrupt the device, it just keeps on going. So completely awesome functionality. So now I will see if I can get back to the AWS console. And where would you be at? All right, we should be back to the AWS console now. So the next step I want to go is great. We've got all this stuff done, but we need to test our business rule to make sure it's actually logging stuff into Dynamo. So let's go up here. We'll browse back to Dynamo. And let's go validate this stuff's actually working, because this is the whole point of it. We want to capture this data. So you can see over the course of time, I've logged almost 7,000 messages into this table. So things have been running consistently for several days. If we go to the items, scroll this, let's change our query so we can actually see what's been published today. Oops. And we want to sort by descending. So that gets us to the last amount of data, and you can see this matches up pretty good with what we're doing. So this is today at 2:53, which was just a couple of minutes ago, or just a couple seconds ago. and our temperature is still 75. And before we looked at it, was down here in the 75.77.76. So great. It looks like everything's been logged as expected. So that kind of is what we did for the demo. Now let me jump back over into the IoT console and talk to you a little bit about the device defender. Because like I said, we want to keep our name out of the news. This is such an easy to use and cheap tool that we should be using it. So if I go to the IoT menu, go to Defend, go to Audit, and let's take a look at the schedule first, because I have this schedule running daily. And if I click on this, these are the rules that are being executed. So these are the predefined rules that AWS tells you. If you pass these, you're doing things probably right. So this is what is scanned across my environment, and it's done on a daily basis. Kind of note when you can do an ad hoc scan, but it takes several hours to compete. I'm sure it's they're doing it on AWS's timetable, not your timetable. So if you want to get immediate results, you have to wait a couple hours before it actually complete all the scans. So let me go back over to the results, and we can see some of the scans that have been running against my environment. And I have 2 out of 4 non-compliant rules. So I can jump into this, and it gives me, here are the things that you're doing wrong. So the first one, which we did on purpose, was this IoT policies overly permissive. And it says over here in the help, says to create and attach policies with the minimum permissions required to do the required task. You can use policy variables to help achieve this. So this is why I chose to do that star, IoT star domain action, is so we'd get this warning telling me, you know what, dummy, you should go back and fix that. But there's also one here that is also a low-hanging fruit, is logging disabled. Yep, you're right. I don't have any kind of logging enabled. So we can fix that pretty easily. It gives you some information. You could go to drill down into it. So here I can click on the account ID that doesn't have logging enabled. And here it jumps you right into the area that I need to fix. So you can see level of verbosity is disabled. I can go ahead and edit that. And in this case, why don't I choose, we'll just log for warnings. So we have to bind a role to it. I already created this role in a previous walkthrough. I'll go ahead and update it. My verbosity is now set to warning. So tonight when my device defender runs against it, does an audit of my device, I should only have the single warning. I should have resolved the security warning for logging. That kind of covers the demo of what I wanted to do today. Let me jump back into the presentation, and we have just a couple minutes left here. So all right, so that should be right. So it should be back to this. So, everything sounds great until you start to know the cost of this. And in this case, when you look at the cost, it even sounds better. I put together a quick cost model, and though it may not be 100% correct, it does get close to what the solution will cost. Since this pricing's built for scale, I'm not really fully taking advantage of the model with just one device. I could add about 10 more devices and for roughly the same cost, which would bring my average cost per device down to about 26 cents a month. So this cost model can scale for thousands of devices without breaking the bank too bad. So if you're curious about any of the hardware components, I've provided the links to the Amazon to purchase them, although it's going to take a while to get them shipped to you. I've also included some links that may be of interest from a technology standpoint. If you care to pick apart my Python code or use it as a reference, I've included it in a public GitHub repository, and I will upload this presentation to there later today as well. And if you're ready to jump in and learn more about IoT, there's a couple of resources available online, or there's actually lots of resources available online. However, I included a couple of courses and labs from the more popular training sites. AWS also has a lot of great material as well. The A Cloud Guru project is very similar to what we have done today, except it uses the Greengrass product if you want to compare the differences between what we did and what Greengrass can do. So my challenge to you is to create your own IoT device. All you need is that multi-million-dollar idea, and it'll make you rich. It's relatively cheap to get started with, something you can easily do for under $100, and it's a great way to get kids started in technology. Start with something simple, implement to get your feet wet, like a weather station, like I did, and use the IoT platform to make your life easier. And then once we wrap up here today, I'll be available to answer questions in the Hardware IoT channel, or I think there's the breakout room also mentioned. Then finally, I got one more.
You're good.
Okay, so finally, I'd like to thank you all for attending this session. And as a thank you, CleanSlate will make you aware of some of the offers we have for our attendees who we found have been of great value. The first offering is focused on our cloud cost optimization because everyone wants to save some money. The second is our planning workshop, which is designed to help you build a strategy to get the most out of your cloud investment. If you're interested, please head over to the CleanSlate Slack channel and someone will connect with you. And thanks again for your time today and hope you enjoy the rest of your conference.